Hey guys, hope everybody's doing okay. What I want to go over today is how to complete single replacement reactions. So you may have done the single replacement lab already, or you may have to still do the single replacement lab depending on how class is structured. But either way, I'm going to show you how to write products for these and to predict the products and to use one of our new reference sheets. So if you remember, a single replacement reaction is simply a single element plus a compound. Okay, so most single replacement reactions look very similar, obviously. You're looking for that single element plus a compound. And anytime you see that and categorize it as a single replacement, you want to use your new reference sheet called the activity series. So it should be yellow. And I have a copy of that on the screen here for you guys to take a look at. So something to take note of or to make sure you know here is that the activity series has the most active or reactive elements at the top and the least reactive elements at the bottom. Okay, so that's going to come into play in a few minutes here when we go through some practice problems. So if you're going to do the lab, you're going to kind of make your own activity series and see if you can get to kind of match up the one that's here. And if you have done the lab already, this is a good review of how some of those chemical reactions worked. So let's do a couple practice problems. You can write these down somewhere in your packet on the lab or on a piece of notebook paper, but you need to know how these work. So example number 1 says silver nitrate plus nickel. So of course you categorize that as a single replacement reaction because silver nitrate is your compound and nickel is your element. Okay? So as soon as you know single replacement, you want to find your yellow cheat sheet, your activity series, and let's see how it works. What I usually tell students to do is to underline the single element. Okay? So let's underline that single element, in this case nickel, and let's find it on our activity series. So the activity series has two columns, a column for metals and nonmetals. And of course, nickel is a metal, so we're going to find it, and it is right here. Okay? What you want to do then is compare nickel to another metal that you have in your chemical reaction. So in our chemical reaction, we have silver nitrate and nickel. So the only other metal that we can compare nickel to is silver. So let's find silver on our activity series down here. Okay, so I circle both nickel and silver. Or I find both of them on the activity series, and I underline both of them in my chemical reaction. Okay? What I want to do now is ask myself, is nickel more or less active than silver is? So of course it is. Nickel is higher up on the activity series. Previous slide, I said the more active metals are at the top. So what will happen here is nickel is trying to come over here and replace silver. Single replacement reaction, right? It's trying to replace silver. Nickel can only replace silver in silver nitrate if it's more active on the activity series. In this case, it is. So in this case, they will switch places. So your element that is now by itself is going to be silver. And nickel is going to create a nickel nitrate compound. Nickel usually likes a +2 charge. So we're going to say nickel 2 nitrate. All right, that takes care of it basically. All that you have to do now is write formulas and balance, which is old news. So let's go through that real quick. Silver nitrate, AgNO3, plus nickel yields silver, which is just Ag, plus nickel 2 nitrate. So that's NiNO3 2. To balance it, put a 2 here, put 1 0, leave them blank, and you're done. So that's how single replacement reactions work. A couple other little things to talk about here. Let's do a couple more examples. Example number 2 is magnesium plus nitric acid. So again, we have an element, magnesium, and a compound, nitric acid. So let's go through and underline magnesium like I did and find it in our activity series right here. And then we have nitric acid. So this gets a little bit weird here. You're like, hey, nitric acid, what is that? Well, it's helpful to write the formula first, I think. HNO3. If you write the formula for the acid, or just know acids have to start with hydrogen, it's kind of like if you said hydrogen nitrate. And I'll write that above here. Hydrogen nitrate. Now you know what to compare it to. Okay, now you know what to compare magnesium to. So students always get caught up with acids, so don't let that happen to you. Underline magnesium, find it, and then you have to compare it to something else in this chart. Well, you see the word acid down here, so it's kind of a giveaway for what you got to do. Hydrogen in acid is here towards the bottom. So I'm going to underline the hydrogen here to see if I'm going to switch it with magnesium. In this case, magnesium, you want your single element, that's important, your single element must be more reactive or active than the element is trying to replace. In this case, it is, so the replacement will occur. So, hydrogen is being replaced with magnesium, so you're going to end up with hydrogen by itself. And then what's left? Students always give me weird answers like magnesium acid or weird things. Well, the hydrogen is being replaced with magnesium. Just move the magnesium over here to where the hydrogen is and rename it. So you have magnesium nitrate. Okay, you're done. So let's go through and write the formulas in balance. Magnesium plus nitric acid gives you hydrogen. Now remember, hydrogen is diatomic, so it's H2, so it's by itself. And then magnesium nitrate, so it's MgNO3 2. Go through and balance it. I think all we need to do is that. And we're done. Okay, that takes care of example number 2. Now you're probably wondering, why is there another column on this cheat sheet? That's because we haven't done one like that yet. So this is example number 3. We're going to use that. So I have iodine and silver bromide. So again, it's just an element plus a compound. Always underline your individual element, like iodine in this case. And then you want to ask yourself, what am I going to compare that to? Well, again, just follow my rules here. Underline the element that's by itself. Find it on your cheat sheet. It's right here. You want to compare iodine to something else on that cheat sheet in the same column. Okay? You can't take iodine and replace sodium in this example. And then you end up with something like iodine bromide. Like, well, that's the weirdest, that's like impossible. So you have to replace it with something else in the same column. So that's why if you follow my rules, you'll be okay. Underline iodine, find it. You have to compare iodine to either fluorine, chlorine, or bromine. Well, in this case, the only other option here is bromide, right? So let's see if they're going to be able to react or not. So find bromide, which is right above it. Okay. Now ask yourself the same set of questions. You want your element by itself, iodine, trying to kick out and replace bromide. The only way for that to occur is if iodine is more reactive or more active than bromide is. And if you look on your activity series, iodine is less active than bromine. Okay? So since iodine is less active than bromine, the iodine is going to try to come over here, kick out the bromide. Bromide is going to be like, I'm more reactive than you, I'm stronger. Not going to happen. So go back over there by yourself. And that's what's going to happen. So you can just put literally NR for no reaction. Okay? These are nice because there's no balancing, there's no nothing. You're done. All right? Now, if the iodine was above bromine, then yes, this reaction would have occurred. Okay? And we would do the same, go through the same process as last time, but it's not going to happen. So if it was something like this, if it was something like chlorine plus sodium bromide, chlorine's by itself, you would find chlorine, it's right here. Compare it with bromide or bromine, it's right there. Chlorine tries to come over here and kick out the bromide, and it could because it's more active. So in this case, your products would be bromine. Okay, when it becomes an element by itself, it drops the IDE endings. It's not an ion anymore. It's just an element, the element bromine, plus sodium chloride. All right? So that's if you had a different example here. And of course, writing the formula for that, you have to be careful because chlorine, Cl2, plus sodium bromide, NaBr, yields bromine, diatomic, ends in INE, plus sodium chloride. All right, so that's what you would end up with for your other, for example, number 3 here. Well, actually, like 3b, I guess. So I wanted to show you one that worked. All right, you'd balance it 2, 2, and you're good to go. One left. Sodium plus water. So I always do this one last because I want to make sure I show you one last trick here. So again, sodium plus water, simple. It's a single replacement. You have an element plus a compound. Sodium is your element, so you find it on the activity series, like I tell you to. And then you have water there. So what am I going to replace? Well, it's not that tough because you see water here. Okay, you see it right here on the activity series. So if you see it there, you're like, okay, what am I going to replace? I'm going to replace hydrogen potentially. How does that look then in our formula here? So it's sometimes easier to write this out first. I'm going to rewrite water to show you guys how to make this a little bit easier. You could write water as H2O, obviously. We know it as H2O. You could also rewrite it as HOH, and you'll see why. If you write water as H2O, and sodium comes in and tries to replace one of the hydrogens, sometimes it's hard to visualize what's left. You know what I mean? So if you rewrite it this way, you know that sodium is going to try to replace one of the hydrogens. Let's see if that happens. Sodium, the element by itself, needs to be more active than the element it's trying to replace. Sodium's trying to replace hydrogen. It's definitely more active than hydrogen. It's above it on the activity series, so it will occur. So this will happen. All right. So you're going to end up with hydrogen by itself. Plus what? Again, students have a hard time figuring out what the other product is here. Well, the sodium is going to come over here and replace the hydrogen. What's left from water? An OH group. You guys know OH is one of our common ions, which is hydroxide. So you're going to create sodium hydroxide. All right? So sodium plus water yields hydrogen plus sodium hydroxide. You could rewrite water if you wanted to in this situation as hydrogen hydroxide, HOH. Then you could easily see what's going to switch. Hydrogen hydroxide. Sodium and hydrogen switch. You're left with hydrogen by itself coming over here where sodium was, and then sodium coming over here where the hydrogen in water was to make sodium hydroxide. So let's write the formulas and finish this. Okay, so, hydrogen is diatomic, so it's H2. Of course, sodium hydroxide is NaOH. Sodium is a +1, hydroxide is a -1. And we have to balance it. And it actually looks like this one is already. Okay, so we have one sodium on each side. Oh no, actually not balanced. Because we have two hydrogens here and one here. Right? So we have 3 hydrogens on that side. So let's just go ahead and try a couple things here. Let's put a 2 here. Let's put a 2 here and here. 1 there. Let's see if that does it. So 2 sodiums on each side is good. 2 oxygens on each side. That's good. 4 hydrogens on the left, and we have 2 here and 2 here. So we're good. So it's all balanced. 2, 2, 1, 2 to balance that equation. Okay. That's it, guys. So there's a bunch of practice problems in a homework set here, or the lab that we're going to do. So either way, hopefully you understand how to do single replacement reactions. Compared to some of our other reaction types, there's much less to worry about here. You have one cheat sheet, obviously, and it works the same way every time. It's not like our synthesis reactions where you have, over 5 or 6 types of those, or your decomp reactions where you have 5 or 6 or more types. Single replacement, it's simple. They all work the same way. One type of single replacement reaction. You're either replacing metal with a metal or non-metal with a non-metal, and it's just about writing formulas and balancing. Okay. If you need any questions, or if you have any questions, let me know. If you need any help, talk to me about it. And I'll see you guys later. Thanks, guys.